Earth is the only planet in the known universe where we have definitively proven the existence of life. Its atmosphere, magnetic field, abundant water, suitable temperature, and balanced ecosystem have made not only the emergence of life possible, but also its persistence for billions of years. Yet humanity has always pursued a profound question: are we alone in the universe? This question is not only a philosophical curiosity, but also a scientific motivation, a driving force for technological advances, and a guide for future searches for life. This is why astronomers search for planets that resemble Earth. These planets are called Earth twins, not only because of their similar size or mass, but also due to the possibility of having habitable conditions. Research proceeds along two main axes: similar planets within our solar system and exoplanets outside the solar system. Venus stood out for many years as the planet most similar to Earth. With a diameter 95% that of Earth and a mass 81% of Earth's, Venus resembles a twin sibling in these respects. However, appearances can be deceiving. Venus's atmosphere is almost entirely made of carbon dioxide, and its thick cloud layers generate a strong greenhouse effect. As a result, surface temperatures reach up to 460 degrees Celsius, hot enough to melt lead. The atmospheric pressure is about 92 times greater than Earth's. These conditions make Venus a deadly hell for life. Nevertheless, Venus research is of great value because it provides a unique example for modeling the extreme outcomes of climate change on Earth. Mars paints a different picture. Although it's about half the size of Earth, there is evidence that rivers once flowed on its surface, lakes existed, and it had a thick atmosphere. Today, its atmosphere is thin and mostly carbon dioxide, and the surface is cold. But dried riverbeds, polar ice caps with water ice, and briny water flows in some regions show that Mars may have hosted a suitable environment for life in its past. NASA's Curiosity and Perseverance rovers are studying Mars's geology in search of traces of past life. Scientists particularly hope to find evidence of microbial life. If such evidence is discovered, it will be a strong sign that life is not unique to Earth in the universe. The search for Earth-like planets has gained real momentum beyond our solar system. Launched in 2009, the Kepler Space Telescope revolutionized astronomy by discovering thousands of exoplanets. Among its most notable discoveries was Kepler-452b, a planet about 1,400 light-years from Earth, 1.6 times the size of Earth, and located in the habitable zone around a star similar to our Sun. It was frequently dubbed Earth 2.0 in the media. Another important discovery was Kepler-22b. This planet is 2.4 times larger than Earth and located in a zone where liquid water could exist. If more information about its atmosphere and surface conditions can be obtained, Kepler-22b could be a strong candidate for habitability. One of the closest star systems to us, Proxima Centauri, is also a significant target. Discovered in 2016, Proxima Centauri b is Earth-sized, located in the habitable zone, and only 4.2 light-years away, making it attractive for future space missions. However, the high radiation from its star could make surface life challenging. The presence of an atmosphere could mitigate this risk, so detailed observations are critical. One of the groups of planets most similar to Earth is found in the TRAPPIST-1 system. Discovered in 2017, this system features 7 planets orbiting a small, cool star. 3 of them, TRAPPIST-1e, TRAPPIST-1f, and TRAPPIST-1g, are located in the habitable zone. This discovery is unique as it shows several habitable planets can exist around a single star. One of the most remarkable discoveries in recent years belongs to Chinese scientists. Announced in 2025, Kepler-725c became a new milestone in the search for an Earth-like planet. This planet orbits a G9 V-type Sun-like star called Kepler-725, about 2,472 light-years from Earth. Kepler-725c has about 10 times Earth's mass and an orbital period of 207.5 days. The energy it receives from its star is about 1.4 times what Earth receives. Interestingly, its orbital eccentricity is 0.44, meaning the distance to its star varies greatly along its orbit, possibly causing diverse climate conditions. Kepler-725c's location in its star's habitable zone means there is a possibility for liquid water. However, the variability in surface temperatures and lack of atmospheric information prevent a definitive assessment for now. The discovery of this planet was made using the transit timing variation, TTV technique, instead of the traditional transit method. The TTV method reveals new planets by measuring how multiple planets affect each other's orbits around a star. especially advantageous for finding long-orbit or low-mass planets. The discovery of Kepler-725c is also important for showing China's rising role in astronomical research. China's new observation techniques and global collaborations suggest even more surprises in the discovery of Earth-like planets in the coming years. There are several basic criteria to determine whether these so-called Earth twins are actually habitable. First, the presence of liquid water is the most critical factor. Water is fundamental for biochemical processes. The second key criterion is the existence and composition of an atmosphere. The atmosphere not only regulates temperature, but also protects the planet from harmful radiation. Third, a magnetic field is crucial for protection against stellar winds and cosmic radiation. Finally, geological activity is needed for the continuity of life. Plate tectonics and volcanic processes regulate the carbon cycle and energy flow. Some candidates like Kepler-452b, ProximaCentauriB, and the TRAPPIST-1 planets may meet some of these criteria. Kepler-725c, although newly discovered, stands out as a remarkable candidate for habitability. However, in-depth atmospheric observations are needed for conclusive results. Future research to unlock the secrets of these planets will rely on advanced telescopes and technologies. The James Webb Space Telescope is already searching for traces of gases such as water vapor, carbon dioxide, and methane in the atmospheres of some exoplanets. Planned telescope projects over the next decades, such as LUVOIR and Habitability, will study the surfaces and atmospheres of Earth-like planets with direct imaging techniques. Artificial intelligence-based data analysis systems will play a key role in processing the massive data from these observations to find signs of life. These efforts are connected not only to academic curiosity, but also to humanity's future. Earth faces challenges such as climate change, dwindling natural resources, and population growth. Discovering Earth's twins will not only help us understand whether we are alone in the universe, but also provide a roadmap for possible future colonies. All we know today is that Earth is a unique planet harboring life. Yet our neighbors Venus and Mars, newly discovered worlds like Kepler-452b, Kepler-22b, ProximaCentauriB, the planets in the TRAPPIST-1 system, and Kepler-725c, all offer strong signs that other habitats may exist in the universe. As research deepens and technologies advance, one day we'll be able to look to the sky and say with certainty that we are not alone. And when that day comes, humanity will finally have answered the greatest question it has asked for thousands of years. The sky offers us not only stars, but other worlds as well. If you're curious about whether we are alone in the universe and interested in discovering Earth's twins, don't forget to like my video, subscribe to my channel, and share your thoughts in the comments. Let's keep looking at the sky together.